This is what we call a work word problem. And in a work word problem, you're given two individuals or two machines or something that are working independently. And then you're also given the situation where they work together. So you're going to be given 2 out of 3 pieces of information. One of the two individuals and their time together, or both individuals and you have to find their time together. So I just think of a really simple formula to figure these out. On one side, you've got the rate of each individual added together, and on the other side, you have the rate of them working together. So keeping that in mind with this word problem, I would definitely pause it if you haven't read it yet or written down whatever you want to write down. But first, we're told that Jason can finish his job in 6 hours. But then we are given that when Jason and Lacey are working together, they can finish in 3.5 hours. So in this case, we're given one individual and we're given their time together. That means we're going to have to find the other individual rate. So for Jason, I think of it as 1 tank per 6 hours. So one job done per 6 hours, 1/6. Now, the other individual rate we were not given, so I'm going to use X for that one. One job done per X hours. So I even wrote on the bottom here, their 2 times individually added together on one side and their time together on the other side. And we were told that it takes 3.5 hours together. So this is what your equation would look like. You would always set it up like this. Very simple. Just make sure it's 1 over each of those times. Now, I have already done videos about solving rational equations. If you know how to solve this, go ahead and pause the video and try to solve it. I encourage you to watch the other videos about rational equations so you have a better idea of what I'm doing. But in order to solve for x, you've got to get it out of the denominator. It would not be considered alone or solved for if it's in a denominator. So what I want to do first is just get rid of all fractions. I know most people hate fractions anyway, so might as well get rid of them first. What I'm going to do is find a common denominator. Now, you may look at this and wonder what the heck your common denominator is going to be, and I'm here to tell you to take the easy way out and just multiply all 3 denominators together, no matter what they are. Even if they have something in common, even if you can come up with something that they all go into, just do this method. It's going to be the quickest and easiest. You don't even have to multiply the 6 and the 3.5. You will see that keeping them separate is actually a little easier. What I'm going to do with the common denominator is multiply all 3 terms by the common denominator. Again, I haven't multiplied anything. I'm literally just writing all 3 of those terms in my common denominator next to all 3 terms of the equation. Now, what happens is the denominator is going to cancel out in all 3 terms. In the first term, the 6's. In the second term, the x's. In the third term, the 3.5's. So you're just left with 3.5 times x in the first term, 6 times 3.5 in the second term, and then 6 times x in the third term. And then it becomes simple algebra. So if you know algebra, you should be good. It's just the setup that people struggle with. But again, if you follow that formula I told you with the individual rates on one side and their rate together on the other, these really aren't too bad. So keeping what I have left, we've got 3.5x plus 6 times 3.5 is 21, and that's equal to 6x. If you know how to solve this, pause the video, solve it yourself. Otherwise, you're going to subtract 3.5x. That leaves you with 21 is equal to 2.5x. Then you divide by 2.5 to get the x by itself, and you find that it would take Lacey by herself 8.4 hours. So it took Jason 6 hours by himself. It took Lacey 8.4 hours by herself. If they worked together, the problem told us it would only take 3.5 hours.